So we're here today with Mr. Strong. We came to talk about our favorite dwarf planet, hopefully soon to be planet Pluto.
Possibly reestablished, yes.
So why does this matter?
Well, you know what? It doesn't matter. It really honestly doesn't matter. In the overall scheme of things, whether Pluto is a planet or it's a dwarf planet, really doesn't make any sense at all. There's no real concept. Because up until now, even through the most powerful telescopes, Pluto has always been a little fuzzy blob. There's just been nothing there. There are moons, but you can't see any detail. There's a planetary surface, but there's just some dark spots and light spots. There's no real reason to get too upset about something that even the best vision that you can get from Earth or the Earth orbit just looks like a smudge. Mm-hmm. Okay, so up until now, there's no real reason for anybody to get upset about it. That said, in January of 2006, NASA launched a space probe to Pluto while it was still a planet. This is the fastest spacecraft that human beings have ever launched. It's been traveling now for 9.5 years. It will be going through the Pluto system on July 14th of this year. Today is June 26th. So in 2.5 weeks, we are going to have Pluto go from a smudge, the best views are a smudge, to as it flies through the system, the cameras are going to take very good, unbelievably crisp images of Pluto's surface, the surface of the 5 moons. They're going to look at the atmosphere. They're going to look at the climate. We're going to get a snapshot of what the weather is like. And Pluto, for everyone on this planet, is suddenly going to go from, oh yeah, that's that thing way out there, to, oh my gosh, this thing is a world. And Pluto will probably be on the cover of Time magazine and Newsweek and all those. It will be on the nightly news. You'll be seeing these close up, and there will be astronomers around the world will be jostling to get to be on TV and go, we never expected to see, and then they're just going to say it. There going to be geysers? Is there an atmosphere around Charon, the largest of the moons? Is there a magnetic field? Is there a ring? These are things we just don't know. We just haven't been there. This is the last large object in the solar system that we have not done a planetary flyby of. And I keep saying planetary, and I keep saying planet because I honestly think that when the International Astronomical Union in August of 2006, before the spacecraft was launched by NASA, they redefined what a planet is and demoted Pluto to a dwarf planet status. And the problems that I have with that, and several other people do, is that I don't think that the definitions were done well. And in science, you're not supposed to just blindly accept things. Just because some authority figures say this is the way it is, doesn't mean that you can't question. And let me just go through it. August 24th, 2006, the International Astronomical Union Resolution 5A definition of planet. A planet is a celestial body, and then it has to meet three criteria. The first is it has to orbit the sun. And if you think about that, that's just ridiculous. We have somewhere between 200 billion and 400 billion stars in the Milky Way galaxy. Does that mean that the only planets that can possibly exist in our galaxy have to go around our sun? That is about as solar-centric as it can possibly be. You know, this idea actually harkens back several hundred years when people thought that the Earth was the center of the universe, and that the planets, the moon, and the sun went around the Earth. Well, we got a little more advanced and we went, hey, what if the sun was the center? Well, okay, the math works about the same and everything looks about the same. But this, to say that only planets, the only definable planets have to orbit the sun is just such a solar chauvinistic concept that it's irritating. That's the best thing I can say. It also ignores the 200 extrasolar planets that had been found up to that point. We now have close to 2,000, but there were 200 known to that point, and everybody at that conference knew about that. You've got to ask the question: what if one of our planets, through some calamity, were to be ejected out of the solar system? Does it suddenly not become a planet because it's no longer going around the sun? It also implies that the sun of all the stars is somehow more than any other star. It somehow makes it special. And for hundreds of years, we've been trying to get away from that. And here, this group of people is almost trying to reestablish that. And it's just not a correct concept. There are estimated to be close to 1 trillion, just as 1 trillion with a T, rogue planets. These are planets that are not going around stars that are probably in the Milky Way galaxy. It's a very odd sort of concept, and that's just the first one. That's just it goes around the sun. Oh, it also takes away any idea of can a planet go around another planet? Can a planet be a moon? You know, I'm sure you've seen science fiction stories where there's a large gas world, and around that is a forested planet. Okay, these folks are saying no, it has to go around the sun. It can't go around anything else. So it can't be a planetary moon. It can't be a rogue planet. It doesn't take into account that systems in the past could be different than systems in the future. And it's a very narrow view, and I don't want to be nasty about it, but it was not well thought through. The second is it has to have sufficient mass that its self-gravity overcomes it being jagged, so it becomes roundish. And the vagueness of the phrase roundish is, again, one of these things that you're just going, this is supposed to be science. You need to tell us what this is. There's one of Saturn's moons, Mimas. Mimas is a really neat little moon. It's just about 400 kilometers across, about 250 miles, and Mimas is the smallest, roundest object that we have seen anywhere. Does that mean that Mimas is a planet? It's only 250 miles across. It's just this isn't a reason for something to be a planet just because it's round. And then the third is it has to clear the area around its orbit. Just because its neighborhood tends to be cluttered with other objects, that seems to these folks cancel out the concept of something being a planet. And I don't think that a planet depends upon where it is. If you were to suddenly take Mars and place it in the middle of the asteroid belt, then Mars is no longer a planet. If you were to take Mars and place it out into the Kuiper belt, where the short period comets come from, then it would essentially no longer be a planet. Right. The location of an object should not be the depender upon if it's a planet or not. It just and then you think, well, at the beginning of the solar system, when planets were being formed, okay, with the asteroids and the planetoids and so forth coming together, then there weren't planets because those planets hadn't cleared their orbits yet. There were lots of things. So if you were to think about it, the current theory of the moon was formed when a Mars-sized object slammed into the Earth before the Earth was the Earth. Those two objects merged, material splashed out into space, it created a ring, that ring coalesced and created the moon. So according to these folks, the Earth before it was the Earth was not a planet because it had not yet cleared the area around it. And so suddenly you're going, okay, so planethood is defined on large time scales. There were times where there were lots of objects in the inner solar system banging into each other. Were there no planets at that point? And then suddenly, after most of them had been cleaned up, suddenly planets appear? No, these are not well thought through. And so the reason for having this conversation is, as the NASA spacecraft, this vehicle that's moving the fastest that we've ever sent anything, as 9.5 years of its journey come to Pluto, and notice I didn't say an end because it's going to fly through the Pluto system, take a bunch of pictures, and keep going. We are going to be up against the concept of what is a planet again, because I honestly think that when we see the surface of Pluto up close and personal, when we see the moons, when we understand what's really going on, when we see the mechanics, the atmosphere, all the geology of what's going on, I think people are going to revisit the concept of what is a planet. And when they do, I think they're going to say, you know what, we need to rethink this. And I think this definition from August of 2006 will be retired. At least I certainly hope so. And what myself and some other folks in a planetary working group are working on is a much better definition of a planet. It's very simple. It's essentially anything that's insufficient to have mass to initiate thermonuclear reactions at its core to be a star. And we've decided we're just going to draw a line in the sand. Anything smaller than this line is not a planet. Anything larger is a planet, and then we're done.
Tell me a little bit more about that. I mean,
sure.
What becomes a planet? That was going to be my next question. If we know if what we have right now is not a good example of what a planet is, what is a good example?
Now, you said what we've got now is a bad example of the definition of a planet.
That was bad science.
Right. Yes. Yeah. It's essentially bad science, and the people that did it are not bad scientists. They, for some reason, did some bad science, and whenever you get a large people in a room and they vote, things don't necessarily come out right. Right. Voting should not be science.
Right.
Okay. You shouldn't determine something by voting. You should determine it by observation and lots of experimentation, and then of course you analyze that. So back to your question.
That being said, what do you think is the smallest? What would the smallest planet count as?
Well, think about it. If you were to take the moon and you were to pluck the moon out of the orbit of the Earth and place it anywhere in the solar system, so it's not going around another planet, I don't think anyone would have a problem with it being called a planet. Okay. Now the moon is it's smaller than Mars, it's larger than Pluto, but not by much. Okay, not by much. But I don't think anyone would have a problem with plucking it out, as I said, placing it somewhere in the solar system. I don't think anyone would have a problem. I also think if you were to take Pluto from its area in the Kuiper Belt, which seems to be the big contention, and you were to place it anywhere in the solar system, I don't think anyone would have a problem with it. But being that it is in the Kuiper Belt and it is one of the largest objects in the Kuiper Belt, then what happens is people say, oh, well, it's a Kuiper Belt object. Well, I don't have a problem with that. I also don't have a problem with Jupiter, Saturn, Uranus, and Neptune being in a colder region of the solar system than the small rocky planets, okay. Mercury, Venus, Earth, Moon, and Mars. So what the working group and I have been working on is trying to come up with as I said, a line in the sand, something that's just tangible, something that I'm sure that you've gone to an amusement park, and to ride this ride you have to be this tall. Right. And if you're not that tall, then you don't get to ride the ride. And if you are that tall or taller, then you get to ride the ride. And nobody has a problem with that. Science needs to be that easy. Mm-hmm. And so being that as we as a spacefaring species move out into space, we're probably not going to take the English system, the feet and yards and gallons and so forth with us. We're probably not going to take the metric system, because the metric system is an Earth-based system. So what we've been working on is what we're calling a universal system. It's the metric system for the stars. And what we've taken is turns out that the very simplest atom, one proton, one electron, right? That gives off a special frequency. It's called the 21 centimeter radio blip. We've decided, let's just make that the standard unit of length, no matter where you are in the universe. A hydrogen line is a known fact out to many decimal places. In the English system, it's about 8.3 inches. Okay. So it makes a nice, holdable sort of a thing. In the metric system, the French took the Earth, took a point at the North Pole to the equator along the Earth's surface. Of course, because these are French doing it, it had to go through Paris, France. They said if you take 10 million times that distance, that's that 1/4 of a circumference. If you take 1/10,000,000th of that distance, that's going to be the unit of length. So the meter, and nobody seems to have a problem with that. So the working group, the planetary working group, said, okay, let's take our unit that we're going to call the wave, and if we multiply it by 10 million, what does that give us? Nobody seemed to have a problem with the meter, so we multiplied it by 10 million. It turns out that distance is about 2,110 10 kilometers across. We didn't do that on purpose. We said, let's pick a unit that anybody can, anywhere in the universe, pick. We know what this is, multiply it by 10 million, and that's going to be our planetary limit. Okay. Anything smaller than that is a planetoid. Anything bigger than that is a planet. And a planetoid is 10 times smaller than that range. Asteroids down from that, meteoroids. And so the entire spectrum is powers of 10 of what we're calling the wave, the little 21 centimeter, 8.3 inch thing. What's interesting is, and we didn't do this on purpose, but it turns out that Pluto is approximately 10% larger than that. Okay. So it turns out that according to this definition, and it's a definition, these folks have come up with the definition, according to that definition, then Pluto would be a planet. What's also really fascinating is that the moon then becomes a planet if you ignore that it has to go around the sun. The 4 large moons of Jupiter become planets. Largest moon of Saturn, Titan, becomes a planet, and Neptune's largest moon, Triton, becomes a planet. Pluto is a planet, and Eris, the body that rivals Pluto, that gave all the problem back in 2005, 2006, because when we found a Kuiper Belt object that was as large or larger than Pluto, then that caused the big ruckus. So Eris would also be a planet. And if you count the current 8 and then the 7 planetary moons and the 2 Kuiper Belt objects, all larger than that, then we have a new solar system of 17 planets. And I don't think anyone's going to have a problem with that. I've had this conversation now for close to 2 years. I've asked, grade schoolers, do you have a problem memorizing, the 17 planets of the solar system? They're going, don't have a problem with that.
Exactly.
No problem whatsoever. And so all that you have to do to make this all go away, you draw a line in the sand and you say, this is it.
Okay.
Anything bigger, it's a planet. Anything smaller, it's a planetoid.
You said 210 kilometers?
2,110 kilometers.
2,110 kilometers. Okay.
Okay.
Now that's the small end. That's how big you have to be to step into the ride.
To step on the ride, right?
Now, what you said fusion, like just being a star,
right,
makes you not a planet. Is there a maximum size?
There would be. This is a lot more complicated. It's real easy to draw a line in the sand for the minimum size of a planet. There's no problems with that whatsoever. Nobody should have a problem with that.
Right.
But as for what constitutes a star, being that it has to do with the mass of the star, it has to do with the composition, it has to do with lots of different factors. You can't just pick a single line in the sand, as I say. So that's going to be a little more complicated. There are some folks that say that anything with a mass larger than 13 Jupiter masses should be considered what's called a brown dwarf. The working group that I'm working with, we want to stay away from words like dwarves and giants. And the reason is, if you think about it for just a moment, in astronomy, there are black dwarves, brown dwarves, red dwarves, yellow dwarves. There's all these weird dwarfs. And then there are giants. There are red giants, there are supergiants, there are blue giants, and you're just, when you sit down and you think about this long enough, you're going, this sounds like a little story that we're telling kids about giants and dwarfs. So we're trying to stay away from the prefixes like that. But the largest, the smallest, I should say, is probably going to be somewhere around 13 Jupiter masses. But that range, there's a range. You'll talk to some people and they say, oh, it's 20. You'll talk to some people, they say, oh, it's 25. You talk to some people and they say, oh, that's 30. There are, if you go into the encyclopedia of extrasolar planets, there's even one, I think I saw it was 64 times the mass of Jupiter. Now, is that a star, or is that a planet, or is it something in between? So one of the terms that the working group has come up with is a world-tar. A world-tar is that boundary zone between planets, which are worlds, and stars. So between a planet and a star, there would be world-tars. These would be things that may or may not have fusion, but they're not full-fledged stars. They're not main sequence stars. Let me put it that way. And so there's going to be a lot more study trying to figure this out. And as I said, the working group that I'm working with, we are interested in, as citizen scientists, coming up with answers. We don't, if the scientific community is breaking down, something has to step in, and a working group of citizen scientists that I'm a part of, that's what we're going to do. Okay. And we're just going to, what we're going to do, we're going to put our definitions out there to force science to turn around and work a little bit harder.
So it's a little bit like a citizen's arrest.
Sort of like that, except we're not going to send anybody to jail. We're just going to wrap them on the knuckles and go, hey, there are people watching. You need to do this right.